Okay, so there's not a Delta Math assignment today, but I want to say a couple of things about Delta Math because I learn more and more as I get in there and start digging around. I didn't think that there was a way, an easy way anyway, for me to make an assignment and it be due at different times for different classes, but I had to get to the end of what I was doing to actually get that option. So I have figured that out. So these two were both due at the end of the day, you know, the day that they were due. But the next time and moving forward when we have Delta Math, it'll be due by the time class starts, just like your other assignments. Does that make sense? As in 2:35. Yeah, 2:35, the end of the school day. But actually yesterday, as I was clicking around and went back, this assignment here, this assignment, for whatever reason, it said 1:35. I know I typed in 2:35, but I don't know what happened. I don't know if I hit something and it went back. I don't know. So there was somebody, as I was looking through like the grades, there was, and actually it was, you were one of them. It said completion was 100, but the grade was 0, which I thought was weird, because then I can click on and see how many questions you did and like how many you got right and wrong. And so basically, then when I hovered over something, it said that I could forgive lateness. And so I'm sure there's a way for me to figure out what time you completed it, but basically you completed it after 1:35, but it should have been 2:35. So I gave you the benefit of the doubt because I also wanted to see what happened. So I forgave your lateness. So I forgave the lateness in there. So I'm telling you that because like if you're absent, when you go in there to do something, you'll have another day on that stuff too, but it'll probably show that it's late and until I get in there and can click a button, okay? But that's good to know also so that when you're late, I don't have to go back and reassign, or when you're absent, I don't have to go back and reassign it. So we're learning as we go. The other thing that I'm learning a lot about is Google Classroom. And it is way easier for me to navigate and probably for you to navigate than Schoology is. And so my plan is, we haven't done a whole lot in Schoology anyway, it's just kind of where I put some information. But I'm going to stop updating Schoology, and pretty much Google Classroom is going to be where I'm going to put everything, because I used to upload the blank notes and homework every single day. That way if you were absent, it was there if you wanted it, or if you lost your assignment, it was there. But it's just very cumbersome. But I figured out a way in Google Classroom to make it really easy. I can drop it in a folder. I don't have to upload anything anywhere. So I'm going to show you what that looks like. So when you go to Google Classroom, this is the stream, which is probably the first thing that pops up. But when you go to classwork, the first thing that's up here now, and I'll probably make a topic for it so it shows up bigger, but there's a folder that says Pre-AP, Pre-Calculus Shared Folder. If you open that and you open the folder, it's going to take you to the Google Drive, right? And you have to be signed in with your district stuff. You would have to be in the Google Classroom anyway. The only folder I have in there so far is this one. We're in Unit 3, so if you open this folder, then the only thing I have in there is yesterday's, because I put it in there for somebody, and that's the blank notes and assignment from yesterday. And so I haven't done today's yet, but I will start doing those like at the beginning of the day, so it's there. So if you are absent and you didn't get the work ahead of time, but you want to get it done, you could print it out and do the notes and watch the video before you ever come back and get them. It's all one file though, so the first 2 pages are the notes, the second 2 pages are the assignment. So you just print out whatever you need, okay? But they'll start to just go like that. Y'all know how to navigate folders and stuff, so I figured that's probably the easiest thing, you know, for y'all to be able to handle with that. Does that all that make sense? And the more we use Google Classroom, I think you'll see that it does become a little bit easier, which means I also put the YouTube playlist links in there, and I'm going to take this stuff out because I can upload it one by one, but that's kind of pointless too if I can just drop it all in a folder and it's separated easier anyway. Okay, and so yeah, that's that. Just wanted to throw that out there. Okay, so let's get to this 71. Is that what page it is? I think. Thank you. Going on page 71, we're done. This is definitely not new, but I don't know how in-depth you went with it and how much you practiced on it and how crazy the problems got, that sort of thing. But we're going to do a lot of solving with exponentials and logs. So here are our steps. We're going to rewrite the equation using a common base. Okay? Use the properties of exponents, so you have to know your properties of exponents, to simplify each side of the equation, and then use the one-to-one property. Okay, so we got a property we can use that says if b to the x equals b to the y, then what do you think has to be true? X equals y. Good. But you got to get a common base before you can do that. And then I'm going to show you why that property works. Basically, like not really the proof, because you'd have to do it differently to be a proof, but what the property allows us to skip. Like what's the math behind it, not just that it's obvious that that has to be true. So let's look at number 2. So we've got e to the 4, and on my board it just looks like blobs to me. We're skipping number 1. I don't know where you're getting 7, but I'm starting with number 2. This is e to the 4w minus 1 equals e to the 5 minus 2w, right? So the fact that they're e problems doesn't matter. I got common bases. That means that the exponents are equal. So 4w minus 1 equals 5 minus 2w. So then when I solve that, I get 6w equals 6, w equals 1. And these are all going to be in set notation because they're all sets of answers. Just some of them will just have 1 in there. So in the space for number 1, I'm going to show you why this works, whether it's an E or whether it's a number or whatever. So I'll just kind of mark that up. Because it's a set of answers. The set just includes one thing. So technically what you're doing, I'm going to rewrite this. E to the 4w minus 1 equals e to the 5 minus 2w. Okay. What the property allows us to skip is, because you don't get to just magically pop them out of the exponents, right, is if I do want this exponent to come out front, then I would need to take the log of both sides. Since I'm dealing with e, I would take the natural log. So I'm going to take the natural log of both sides. So when you do that, then the exponent gets to come out front, right? So we would get 4w minus 1 times the natural log of e equals 5 minus 2w times the natural log of e. Right? What's the natural log of e?
2.7.
No, not what is e. Yeah, I don't want to know what e is. The natural log of e. What's the base of that log?
2.7.
Oh, good Lord.
No, it's e.
Okay.
It's e. It's e.
So the natural log of e, if I say it equals x, right? What's the base of this log? It's e. So e to the x power equals e. What's x?
0.
Oh, good God.
1.
1. It is 1. Remember that log property we have, that log base b of b equals 1? Right? That's important. That's the property you're using here. Okay? So if we had done number 1, I wouldn't have taken the natural log of both sides. I would have taken the log base 3 of both sides, because then the log base 3 of 3 equals 1. Does that make sense? So basically you're just taking the log of both sides, and that's what allows you to bring it out. But we get to skip all that because of the one-to-one property. You with me? So we're not going to have to do this part, because then since those both equal 1, that's where you get that from. Okay? So we're just having to do that. That's where that one-to-one property comes from. All right, so let's look at number 3. So I know what my common base is going to be, but I don't have just one exponential on each side. So these two are being multiplied together, which means I do what with the exponents? Add them. So this becomes 5 to the c minus 1 plus 3c plus 2 power. I add these two exponents because that's what happens when you multiply the bases. So when I add them, this gives me 4c plus 1. That's equal to 5 to the 7c plus 16 power. Now I have a single base on each side. They are the same. Now I get to pull them out of the exponents, and I get 4c plus 1 equals 7c plus 16. So c equals negative 5. What questions do you have? All right, y'all work on number 4. So remember that your goal is not just to get the right answer. Your goal is to get the right answer and show the correct process in the process. There's not a single thing that I wrote down that you can skip. Not a single thing. Okay? So if you did, you lost out on a point somewhere. Because you have to get the common base first. You can't just go ahead and add them and know that that's what's happening. Like you got to show, I have this, now you're using the one-to-one property to get to this point. Okay, it's okay to like combine things as you're going. You can kind of skip those steps. But then I have to set it equal to 0. Then I have to factor it. Then I get my answer. And notice along the way, equation, 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 equation. Right? You cannot lose the equal signs. You have to have equal to 0. Otherwise, you are not saying what you think you're saying. Okay, does that make sense? Those are important little things that may seem nitpicky, but okay, you can call them nitpicky if you want. You can lose the points, whatever. I'm just trying to help you out. Okay. All right. So then let's look at number 6. On number 6, what would you want to use as your common base? Yeah, I would not use 9. That would make it really, really hard. Yeah. We'd use 4. Okay. Could we use 2? We could. We don't have to though. It'd probably be easier to use 4. So the biggest number you could use is really the best. That's a matter of opinion, but the easiest. Could I use 1/4 instead of 4? I could. Like there's options here. We could have a different work and get the same answer. All right. So 4 to what power gives me 64? Now listen to my question. 4 to what power gives me 64? 3. Okay. So the fact that it's in the denominator, that's why it would be 4 to the negative 3 power equals 4 to the a squared minus 4 power. So that means negative 3 equals a squared minus 4. Okay, and then you can just go on from there. Finish it up. Okay, could I have solved that differently? Yes, I could have here added 4 to both sides and gotten 1 equals a squared. Then when I take square root of both sides, I still get plus or minus 1. The danger of that process is not doing plus or minus, which most of us are past by now, and we can get that plus or minus, but not everybody. So be careful. But either way works. Like, there's your factoring way, but that's another way to solve them, and it's fine. Okay, so let's look at number 7. What would our common base be in number 7? 2. Yeah, there you go. Okay, so I already have 2 on the left-hand side, so this is 2 to the m minus 9 equals, and then this would be 2. 2 to what power gives me 32? 5. So this is 2 to the 5 times m plus 3 power. I got my common bases. Even though I haven't distributed the right-hand side, I can go ahead and take them out, and I can distribute as I do that. So I get m minus 9 equals 5m plus 15. So then this will give me negative 24 equals 4m and equals negative 6. Okay. All right, what questions do you have? Just something you got to practice, right? All right, you do number 8. What questions you got? Do you agree with me here? Maybe. Okay, we good? All right. right, so we're gonna, on the back, we're not necessarily gonna work through the whole thing on all of them, but we'll just go through and set some up to make sure we know how to handle what we're doing. But we're good so far? All right, awesome. So flip over. Let's look at number 9. So what would you use as your base on number 9? 7. Would 7 work? Okay, 7 works. Could I use 1/7? Yes, either one, doesn't matter. Okay, so if we use 7, 7 to what power is 343? 3. So this would be 7 to the 3 times 2n minus 4 power equals 7 to the what? Negative 2n plus 4 power. Yes? And I feel like if you can get that far, you can get the rest, so we don't need to work through it. Let's look at number 11. Could I use 9 as my base? No. So 9's not an option. What would I need to use? 3. So I'd have 3 to the 2 times negative p power equals 3 to the, all right, what power there? Yeah, I count on my fingers too when I do this. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, so that's 5. Okay, of course I counted wrong on my fingers last period, but 5 times 2p plus 6, so not only can you count, just make sure you count correctly. Then once you get there, the rest is a basic algebra equation, right? All right, we good on those? Yep. All right, I want y'all to do number 12, the whole thing. If you're done, check your answers with your neighbor.
Don't look at Miss Finn.
Yeah, what did you do? Mm-hmm. Thank you, Rico. Mm-hmm. Look at that basic math kicking your butt over there. Okay, raise your hand if you did not use 4 as the base. Okay, what'd you use? You used 1/4? Okay. Is that okay? Could we do that? Yes? Anybody else use something different than 4 or 1/4? I thought I saw a couple of people. Nobody wants to speak up. So, did some of y'all use 2? Because it looked like I thought I saw some people using 2. Did you use 2? Use 2? Okay. That's fine. Why are you afraid of that? There's nothing wrong with it. My point is just that there's different ways to do it. But we should all get the same answer in the end if we did it correctly, right? So since I know most people did not do it in fraction form, you don't have to change yours. You don't have to write mine down. I just want you to see that you could leave it like that. If they're both in fractions, to take it out, I'm going to get negatives, and then that's where sometimes we make our mistakes or whatever. But I can leave it. I could use 1/4. I could even use 1/2, right? But I'm going to use 1/4, and these little exponents look like blobs up here sometimes. So I'm going to leave the left-hand side. This is going to be 1/4 to the 2x squared minus 6 power equals, this is going to be 1/4. Your fractions always have to be in parentheses. And then 4 to what power gives me 64? 3. So this would be 3 times 2x squared minus 5, right? So now I've got a common base, which might be different than your common base, but I still got a common base. So now I get 2x squared minus 6 equals 6x squared minus 15. And so then this is going to give me 0 equals 4x squared minus 9. And I can factor that to 2x plus 3, 2x minus 3. So my x values plus and minus 3 halves. Now, again, could I have worked the end part of that differently? Yes, I could have set 4x squared equal to 9, divided, and then taken the square root. But if you're doing it that way, make sure you're doing that legally when you can do it. And sometimes you'll seem to make stuff up. And then you don't forget your plus or minus, and it's fine. It's just different ways to do it. Yes, sir. Uh-huh. So you have to multiply this by a -1 and this by a -1. And your first step here would look different, but then as you go, it'll end up being the same. -3. Yeah, -3. Yeah. All right, any other questions? I just want you to know that there's different ways, so you don't have to argue with your neighbor about, you're not doing it right. At the end, we should have the same answer. All right, so number 13. Can 36 be my common base? Well, 36 squared, is that 216? No, even if you don't know what it is, you know it's not 216, so 36 is not an option, right? So what would my base have to be? 6. Good. All right, so let's look at 14. Let's think about our options for our bases. Could I use 25? Yes. Could I use 5? Yes. Could I use 1 over either one of those numbers? Yes. Okay. So absolutely nothing wrong with using 5, but again, the bigger the number you use, like the easier it is as you go. So if we do 25 here, we're going to get 25 to the a power times 25 to the what? Yeah, 2 times a plus 3. You need to know your perfect squares of 25 equals 25 to the negative first power. So then that means we get 25 to the, that's going to be a plus 2a, so that'd be 3a plus 6 power equals 25 to the -1 power, and then you can finish that. Okay? You don't have to finish it, but I know you're capable of it. On the homework, you have to work them all the way. We don't have to do that on every single one of these. Yeah, you don't get to just set them up and move on. All right, so let's look at number 15. Can I use 16 as my common base? No. Could I use 4? Yes? No. Yeah, I could use 4 if I just had these two numbers, but I can't use 4 because of this, so I have to use 2, right? So this is going to be 2, well, 2 or 1/2, right? Either one. What do y'all want to use, 2 or 1/2? 2. Okay. So we get 2 to the, it has to be a negative what? 4 power. 4 times x plus 7 times 2 to the 6th times x plus 5 equals 2 to the negative what? 5 times 4 power. So then that would give me 2 to the negative 4x minus 28 plus 6x plus 30 power equals 2 to the negative 20th power. So now I have a common base, even though the exponent on the left looks yucky. I can combine that as I take that out. So I get 2x plus 2 equals negative 20. 2x equals negative 22. X equals negative 11. Okay. What questions you got? All right, then y'all do number 16 while I hand out the assignment. I don't want to take all the fun away from you. Okay, so one reason that I would encourage you on questions like this to not do it this way and do it this way even though it's not wrong is because if you get in the habit of just every time you have a quadratic, you set it equal to 0 and you solve it that way, then when you get to situations like this, you won't make stuff up. Because I absolutely cannot do 8y squared equals a negative 6y and divide both sides by y. That's a big fat no, okay? And I see things like that all the time, unfortunately. Shouldn't be seeing that in a pre-AP pre-cal class, but heck no, you don't get to just divide through by y. You can factor it out.
Why can't you do that?
Because if I did that, I'll help you out. You can let your friend know, all right, that if you have 8y squared equals negative 6y, and we just divide both sides by y, right, so those cancel out, and one of these cancels out, then I get 8y equals 6, right? So then that y equals, negative 6, I'm sorry, equals negative 3/4. Right, but what's the real answer? You lost a root. When you divide that out, you lose a root. It's no longer a quadratic. You should have two answers there.
Wouldn't it be the same as like factoring out a y and then the y is equal to 0 anyway?
Right, but it's still there. Like this has disappeared. It's gone. Like you don't even have anything to say that. But yes. So make sure you explain that to your friend, okay? All right. He's not an idiot. I appreciate that he asked.